That's good. That's good. We're not making enough horsepower. We need VHT on the tires here. Whenever the vehicle's running, we're going to have the fan going. Right by your feet, there's a plug, and right there's an outlet. That will circulate the water between the two barrels. After about the third vehicle, you'll actually feel the barrels getting quite hot because all of the horsepower that's being absorbed is being converted into thermal energy in the water. There's a panel on the other side of this post, right here. The lower panel shows vehicle speed and horsepower. So even if you can't get up close to see what's going on, you can monitor the speed and the horsepower. The video screen will show what the scan gauge shows. We have a scan gauge rigged up with the camera looking right at it so that we can see what the scan gauge sees.
This vehicle, we brought it in this morning and just kind of went over it. The optimizer is mounted in the engine compartment on this particular vehicle. If you mount them here, just, you know, really, you want to try and keep these out of the weather the most you can. We're going to go ahead and check our amp draw on the fuel cell, and then we're actually going to do the tuning part of it, which seems to be the hardest problem that everyone's struggling with. So we got an amp clamp here. You want to zero out your amp probe or amp clamp. Okay, I got my voltmeter, that internal, that P6 terminal inside your optimizer. We're going to monitor that with the voltmeter. That way you can, as I'm changing the settings here, looking at my scope, we can also monitor the voltage that's inside the optimizer. Okay, this up here is a digital voltmeter also, which would be the same as if you guys had one of these voltmeters hooked up to your O2. I'm gonna show you guys the oxygen sensor in the optimizer when it goes in, and the signal coming out of the optimizer to the PCM. You guys are gonna see that in graph form. That's what the computer looks at. Once we get this thing warmed up, we'll go ahead and put it under load. You'll see that oxygen sensor start to switch. Now this is that, let's say this vehicle did not have the optimizer right now. You guys got this in the shop. This is that voltage I'm telling you on the O2 you want to monitor. If it's real, let's say we had one, see how it dropped off right now? The oxygen sensor's got to be at 600 degrees or better for it to operate. That's why they cool off at idle sometimes, and the computer ignores them. It'll go into open loop at idle sometimes. But what I'm really trying to get at the most is, let's say you got a vehicle under load that's not, this is what you got on your O2, it's just flatlining there at the bottom. You want to give it some propane. Spray some propane over here, inject some propane, and see if that O2 jumps up. If it does, your O2's good. You just got a problem with the vehicle running lean for some reason or another. Vacuum leak can cause an O2 reading lean like that. This is what the P6 terminal is there for. That pot right there, you can adjust it so much. It's like a carburetor, but a carburetor usually you only turn it a turn or two to get in that. This thing you're able to. This is an internal voltage used as reference. Let me give you an example. Once I'm done tuning this where I like my readings, everything looks good, I'm gonna write that voltage down with a permanent marker under my cover and cap it. Two reasons. One, you mount your optimizer here and a customer sees a rubber plug, what's the first thing he's gonna wanna do?
Gonna get his finger pulled.
If they adjusted it, I can do it what? Better?
Yeah.
That's what they're gonna wanna do. Now, if you reference that voltage and you mark it underneath your cover, I also put like some tamper paint here once I'm done tuning it, just in case. Especially if you put it in an area where they're going to be seeing it. You're always going to have them customers that are going to want to fool around with it or try and tune it better than you did. They brought it to you to install it, but they can tune it better. Okay? That's your only way to know, hey, did someone fool around with this, or did it move on me, or, you know. That's what that rubber plug's there for. It puts a little bit of pressure on that pot so the screw doesn't vibrate with vibration and stuff. So basically that's what we're monitoring right now. You'll see as I make my adjustments here, this voltage will also change. So we're gonna be looking at our O2 sensors. Mike, can you put it in drive? Give me about 1,500 RPMs, 1,800 RPMs. That's our oxygen sensor before it gets modified. That's our P6 terminal. Now I'm going to switch over here. That's the optimizer right there. You guys remember that pattern I drew out for you? Yeah. All right. Look at that. We're getting it. See how that square wave staying red. Lean, red. Look at the time that we're staying up longer on the ridge than we are in the lean. We're under a good load, and we've got about 3 times the time frame that we're staying on the ridge, which is a lean command. You guys understand that? We could measure that. That's what we're looking for. Look at that signal. It's starting to look better. That's about what you want right there, guys. I like it right there. It's switching, that's what the computer wants to see, but we're staying at a longer period of time up here. See, that's how long it stayed on the lean side. Yeah. That's the only time it demanded fuel. So all this time up here, we're taking away fuel. Giving it fuel, taking away fuel. Giving fuel, taking away fuel. That's what you want to see. So now, our internal voltage is going to be 0.204. They come factory set, I think, at 0.16. So this one ended up being, they're all different. Don't go home and put yours at 0.204. They're all different. Okay? That's a good reading there under load. We're drawing 16 amps now that we're nice and hot. I wouldn't do a final tune if we were at 12 amps because that means we're not getting that water gas. Okay? You want to do your final tune when you're getting your amperage test and you do your 1 liter and 1 minute test. Okay, Mike? Give me idle now. Just go ahead and put it in park. Dennis, can you hand me over the bottles to do the liter test? I'm gonna tell you with a voltmeter. See up here, there's a voltmeter. You can still see that with the voltmeter. As long as those numbers are staying higher on above 500 millivolts than they are below 500 millivolts, that's what you're looking for. So no, you don't need this fancy piece of equipment here. Watch. Let me put my hand over it. You see those numbers? You can tell just by looking at them, they're staying longer over 500 millivolts than they are under 500 millivolts. You're in the ballpark under load if you're doing that. Well, the reason why I like checking it here is because you're checking through the dryer and everything.
Yeah, okay.
If we check it here and there's a restriction here, we want to check it over here. You don't want to check it at the cell.
We want to check where it goes into the air cleaner,
Right.
right?
That way you just verified your whole system. All right. Thank you. That's what I was looking for. All right. Who's got a stopwatch? We got one hanging over there.
I got one here.
All right.
Can we win?
Okay. Ready? When?
Go!
Now you got to make sure you got a positive seal. This one's been used about a jillion times, but I guarantee you it's flowing pretty good. You can see that water gas.
That's 30 seconds. That's pretty good.
Well, you got to give it a little bit of time to fill up the chamber.
Flowing when I hit the button exactly.
Yeah.
45 or so. Five, 8, 9, 10.
All right. It's pretty close. All right. Okay, guys, look at. Go ahead and take that out. This thing looks pretty efficient to me. It's flowing a lot of water gas. Looks good. The reason why I like testing it here, if you got a problem with your dryer, a pinch line, you check it out of the fuel cell. You just tune this thing. You go out on a road test, you don't get no good results. When you test it here, you're verifying the whole system in between. Okay? Now, this one right here, we're gonna end up being anywhere like 0.203 to 205. I had it set around 0.203 earlier. It changed just a little bit. Where's that cover at?
Right
All right. That's about what you're gonna do right there. I put 0.203 at P6 right there. You could always use that as a reference now. That's where you calibrated it. And also, if your customer messes with it, you'll know. There's no other, that's what that terminal's there for. So you don't have to sit there and count how many times you crank on that screw. Yeah, exactly. It's too hard. Someone was smart and they built that terminal. So that terminal has nothing to do with this voltage. It's just a reference terminal that's affected by that pot. So it's a reference terminal. That's all it is. A lot of people get confused and they try adding that voltage to this voltage, and that's not what it's for. Okay, so we're gonna put this cover on. To me, this one's ready to go test, guys. It looks good. I know Mike had talked earlier about you guys going and testing. Mike, can you see if you could find us field trim in there real quick and then cover it back up if you get me that PID, the data? Short term, long term. What are those numbers showing, guys? Negative. That means we're taking away fuel. Exactly. Okay. All right. You guys get the idea now?
Yeah, oh yeah.
If you're comparing all these and referencing all these together as you're tuning, you know 100% that you're taking away fuel. That's basically what that's telling you.
What would those trim numbers normally be before you've done any of this?
They hang around 1
They-
to 5 days.
They'll fluctuate from 0 and they'll come up and down, but this tells us right here, it's constantly at 0 or negative. Let's say, I'm gonna give you an example. Let's say we have a big vacuum leak. The engine's running lean. Those trim numbers are gonna start climbing because the computer's compensating for the vacuum leak and it's giving it more fuel. We're actually doing exactly the opposite. We're leaning it out and we're tricking it, okay? We're giving it an actual input that it's rich. That just verified that the ECM's taking away fuel. Those numbers right there, those just gave you that assurance.
Yep.
Mike, go ahead and turn it off. Now go ahead and fire her back up.
Back to 0.
Okay.
Your
Go ahead and-
optimizer reset too. It's
Right.
got to go through the 5-minute countdown, right?
Yeah. Not on the O2 though. All right. Does it look like it's holding? Yeah. All right, we got this sucker tuned. Okay, guys, you see that once you guys get everything established, when a system's wired properly, fuel cells are flowing good, that's a 110% verification that you're taking away fuel. So now we're ready for the orange test on this vehicle here, and I'm pretty confident that it's going to be good. Look how long it took us to tune it. Okay, when you get a vehicle in here that's the wires are hanging all over, the fuel cell hoses are melted, and you know, it's like, how can you tune something like that? When everything's done properly, the tuning part's not too difficult once you understand those numbers, what we're trying to accomplish there. Yeah. Do any of you guys have any questions before we go on the orange test on this one? No questions? You guys all understand it? Now's the time to ask, guys. I mean, I'll answer any of your questions. Does that make more sense to you guys now that you actually like seen it?
Yep.
See, I think that's what. All right. Now, if you want to take it a step further, let's say this one passed the 50%. I mean, that's what we're guaranteeing them. Why are you going to spend 5, 6, 7, 8, 9 hours making, you know? Exactly. I mean, if it's already getting the 50% or better, I mean, I'd leave it unless it's your personal. I mean, the Honda, I mean, I sat there, the one I did that got 109, and I'm still messing with it. I'm trying to get even more out of it. Really, once you guys get over that 50%, that's what you're guaranteeing them, as long as you educate your customer to, you know, you can see that if that fuel cell were to drop amperage, it's going to affect. So, you know, maybe it's good once in a while they bring it in and make sure it's flowing those amps, you know. As long as they're educated and, you know, you sell this to a customer that's definitely going to be interested in putting distilled water, adding the covalizer. Now, this is another thing to look out for because I've been doing quite a few of these and this is what I'm seeing. Customers are going to tell you they're doing everything right. That's what they're going to tell you. I've seen cases where the amperage is correct, but we didn't pass that 1 liter test. Okay? You get minerals, impurities in there, that's going to cause current to flow, but we're not making water gas. What does that tell me? That tells me my customer's not putting distilled water in there. That's what it tells me. Or they mount, I mean, it's possible that thing could have a lot of debris. They're not using a funnel and they're pouring it in. Well, when that water hits the fuel cell, all that dirt and everything goes inside. It's very critical that you educate them how important it is to keep this system clean. Those contaminants will cause that amperage to go up and the water gas level to possibly go down. Or you could be on target with your amps but fail your 1 liter in 1 minute test. The whole idea is that we take away fuel from the engine because we're giving it water gas that has 5 times the potential, and that's where we're coming with that balance. Now, if we're not making water gas, that's where drivability problems are going to start coming in because the engine's not getting that water gas. What did we tune it to run with? 1 liter in 1 minute, that water gas. So definitely that's where the drivability problems come from. So if you guys stay on top of that, there shouldn't be any problems. This one's ready to go. Let's button it up. You got the first screws? Yes, sir.
If I'm doing this and I don't have the use of the bar graph to do it, you're watching
The-
the actual O2 sensor
Voltage, yes, sir.
And as long as we want to stay 5 or higher for most of the time.
Well, you want to see it switch,
Right.
but as a percentage, do you remember that bar?
Yeah.
That square wave? Okay. If you were to compare that, let's say to that, that's 1, 2, 3, 4 times longer it stayed rich than it still switched, but it's staying longer.
They stayed low long.
Yes, it's keeping the computer happy because it's still switching, but
It's still dipped
But
below
it's staying-
500, but you want to keep it more.
but it's staying longer in the side we want it to,
Right. Okay.
the taking away side. Yeah, there should be no water coming out.
No, but why is it?
Why is it?
Yep,
And you're at how many amps?
12.6 amps, not even at 15.
Not even at 15. You got a dirty fuel cell.
That's what I was suspicious of.